Hello guys, how are you doing? And it's Jalaj Aura here again, back with another video from Biogem at GCSE Chem. And today we're going to be doing section 2.1, C2.1 of the GCSE Chemistry Caboodle textbook. My battery is quite low today, only 6%, so I'm going to have to hurry up a bit. But just before I start, yesterday the only mistake I made in C1.8 was that when you're meant to draw the electrons, basically in clockwise direction, so in this direction. So I did that, but then when I was moving my hands I actually did this. So whenever you're drawing electrons, so obviously the first two electrons you do above and below the circle, and then after that for the 8 electrons you do one here, one here, one here, one here. It's a bit like north, east, south, west. So it's like never eat shredded wheat, and then you double up again. There. So it's basically you're going in this direction, not this direction. Remember, you're going clockwise, not anti-clockwise. So I just wanted to show that. I think I've already shown this before, but this is the revision guide I'm using just to show you again. And yeah, I'm gonna have to hurry up today a bit with this. But today we're doing C2.1 actually, which is really cool. It's about development of the periodic table. So let's start. During the 19th century, scientists tried to find So C2.1 development of the periodic table. So during the 19th century, scientists tried to find patterns in the behavior of elements. At first, they arranged the elements in order of atomic weight. So that's atomic mass, the mass number. So originally, they actually arranged the elements in increasing mass number. And by the way, today I'm filming in my room and not in the lounge where I normally film, because obviously, my parents are watching television downstairs, so didn't really want to disturb them. So I had to kind of come upstairs, and it's good, it's something new anyway. But yeah, so during the 19th century, scientists tried to find patterns in the behavior of elements. At first, they arranged the elements in order of atomic weight. So that's atomic mass. In 1864, Newlands proposed his law of octaves, which he based on the order of atomic weight, and said that the properties of every eighth element were similar. However, new elements were being discovered that did not fit his table. Other scientists did not accept his ideas, and the elements in his octaves did not always have similar properties. So obviously you can see elements, the scientists didn't really accept his ideas much, and his, when new elements were discovered, his kind of table did kind of start to break down, not fully work, because every eighth element didn't have similar properties. So this is an example of his law of octaves. If you can see, so here for example, the first element, which is hydrogen, then the 8th element, they were in the same group, then the 15th and the cobalt and nickel 22, so they would have been in the same group as part his rule. But obviously, that isn't the way that we do it nowadays. So obviously many people rejected his, because it wasn't exactly true. New elements were being discovered, and his pattern broke down of every 8th element. They didn't have the similar properties that he was saying. Yep. So did not have similar properties yet. Yep. So here's a question: how were the elements arranged in the early periodic table? Well, they were arranged basically according to their atomic weight or mass number. They were arranged based on atomic weight. I just want to see myself. I'm pretty sure I'm right here. Just want to make sure that's the question. That's the answer they're looking for here. Should be right, but just good to check anyway. So where is it? 1 minute, sorry guys. There's that, in order of atomic weight, yeah, or mass number. You should say atomic weight, because it says atomic weight in the book. Ooh. Yeah, I'm a bit tight for time today, 5% left. In 1869, Dmitry Mendeleev, his name was, and Newlands, his first name was John, so it was John Newlands. But in 1869, or Dmitry Mendeleev, placed the known elements in order of atomic weights. in order of their atomic weights, so that a pattern in the properties could be seen. In some places, he changed the order of the elements so that elements with the similar properties were in the same group, and he left gaps for undiscovered elements. So what he did, he kind of, he placed elements in order of atomic weights as well, and he could see a pattern in their properties, and he kind of changed the order of the elements so that elements with similar properties were in the same group, and also he left gaps for undiscovered elements. Now that's one very big thing that he did. He left gaps for the undiscovered elements, which was very, very crucial, actually, as new elements were being discovered at the time. So he used his periodic table to predict the properties of the undiscovered elements. When these elements were discovered, they had similar properties to his predictions, and because of this, the other scientists accepted his table. Now, his table was accepted because the predictions that he made based on the existing elements was actually very close, to the actual predictions for the undiscovered elements that had been discovered, basically. So later, scientists discovered more about the structure of the atom, and knowledge of isotopes explained why some elements have heavier atomic weights than expected. So because of isotopes, scientists were able to explain why some elements obviously had heavier atomic weights than expected. And now here's a picture of Dmitry Mendeleev, just to show you. And what it just says about him, we're nearly done, but what it just says about him is that Dmitry Mendeleev, on a Russian stamp issued in his honor in 1969, he is remembered as the father of the modern periodic table. So he's known as the father of the modern periodic table. Using the table, chemists can now make predictions or make sense of the chemical elements. It says. Why did Mendeleev leave gaps in his periodic table? Number 2. That's question number 2, and that's basically he left it for undiscovered elements to that's the basic main answer. I just want to kind of see, just to make sure I'm on the right track here. But he left gaps for the undiscovered elements. That's exactly what it says. Yeah. This topic doesn't come up a lot in A-level chemistry, so I'm just checking my understanding. Although I'm pretty certain I know it, I just need to check sometimes that, do I actually know it? And yes, I do, because I got it right there. Now, if you're following the student book, I should say this before the big book, it's pages 22 to 23 that you should be on. So yeah, I've really got to try and get into the habit of saying that before. So yeah, but key points now, just before we finish off. The periodic table of elements developed as chemists tried to classify the elements. So obviously, periodic table of elements developed as chemists were trying to classify the elements. It arranges them in order of in an order in which similar elements are grouped together. So the periodic table is arranged in which similar elements in such a way the periodic table is arranged in such a way the elements in the same group basically have similar properties. Similar elements are grouped together. And next point is that the periodic table is so named because of the regular repeating pattern in the properties of the elements. So irregular repeating patterns in the properties of the elements. That's why it's periodic, because it's a regular repeating pattern in the properties of the elements. So periodic, it happens again and again, a regular repeating pattern. That's what it means. Now, Mendeleev's periodic table left gaps for unknown elements, which when discovered matched his predictions, and so his table was accepted by the scientific community. That's why his table. That's why Dmitry Mendeleev's periodic table was accepted over John Newland's early ideas over his table. So that's all there is. There's no keywords in this section here, but I really hope this was useful. Make sure to share, like, and subscribe. Really helps the channel out, and thank you for your support always. And so tomorrow I will be doing C2.2, which is electronic structures and the periodic table. So that's linking what we did from 1.8, C1.8 electronic structures with the periodic table. So that's going to be good. Also, I just want to say, obviously, make sure to turn the notification bell on, just in case you haven't, so you are updated, when you're notified when I upload new videos that you can watch. And yeah, and also one more thing, I've started to make a new website of my own, which is be a gem at GCSE Chem. I'm still working on it. So if you type be a gem be a gem at GCSE Chem on Google Chrome, you'd see the website, and basically I'm still kind of working on it, trying to make it better. But basically it has all the videos that I've made so far till C1.8, and I'll be uploading this one there as well. I'll be putting on the website as well, and I'll be putting on my YouTube channel as well. So feel free to check that website out as well. And it's just, hopefully that website's just going to get better and better, hopefully, with the new additions. So that's all I had to say in this video. I hope it was useful, and make sure to share, like, and subscribe. And I'll see you in the next video tomorrow. Thank you very much, guys.